In this video, we'll go a little bit more in-depth into what makes Rust code idiomatic or rusty, and how that can have benefits for both users of your code when you write it and package it as libraries, and also your own applications. In this video, we'll talk about breaking up code with modules. Now, you've seen how to create modules and how to put code in different files, but why do we do this? The basic reasons are that it improves readability and discovery of both code for you and other contributors if you are working on a project with multiple people, and of documentation, but only if you do it right. The best way to break up code is by functional units. Each module should export a few symbols, a struct or two, perhaps some traits and functions, but lots of cross-coupling is a bad sign. Remember, we're doing this so that 1, the code can be functionally separate, but 2, so that people can figure out how the codebase is structured without having to read a whole lot of documentation. So, for example, in this crate, it does some network operations, some rendering, and talks to a database, and I can see that just by looking at the module structure. I can also immediately see that it supports both IPv4 and IPv6, and supports Postgres and MySQL in terms of database backend. If there's a bug that only happens on Postgres and not MySQL, the first place I would look wouldn't be in the rendering or network crates, but would be in the database : Postgres module of this crate. That's because we named things clearly and separated them by functional units. If you have a lot of complex structs, it can be useful to make multiple submodules, one for each struct, and of course, this applies to other types like enums. All implementations for these types should be in their module. The module root can then re-export them in a flat way. For example, here we have a crate which has a module called module, and within that module there are submodules, person, pet, and car. Each one of those could have even their own submodules, but certainly they will each define one type, person, pet, and car, and they will define various behavior for those types. Module will then pub use person : person, pet : pet, and car : car. Cross-coupling between modules, and especially between levels, is a code smell or a symptom of bad design. Use visibility modifiers to access implementations only where they're needed and control their access in other places. For instance, fields and methods that are not marked pub cannot be used outside of the module in which they're declared, though they can be used in submodules. Here, we see 2 modules, one of which contains person and pet, and one of which contains car and fish. Pet and fish are in different modules, but pet appears to depend on some features of fish, and the second module appears to require contents of pet, which is in the first module. This is not a good thing, and if you see it happening in your codebase, you should consider reorganizing your module structure. For many architectures, testing within each module is sufficient for unit testing. If necessary for organization, tests can be placed in a submodule, generally in the same file, but if there get to be a large number of them, they can be split into their own modules. It's very important to document your code. No matter how good your module structure is, someone cannot simply look at that structure and determine what each piece actually does. So, while separation of modules into functional units can improve discoverability, you do still need to document your code.